Welcome back. We continue our discussion on calculus, where we are looking at differentiation using the first principles. So we have this example on the board: differentiate using the first principles. So the first principles that we are referring to is here. The first principle that we are referring to is here. You can see we have f prime of x is equal to the limit of this as h approaches 0. Where you see f prime of x, this is the same as dy dx. So don't run away after seeing f prime of x. This is the same as dy dx. Okay, so this is what we call the first principle. Let's use the first principle to differentiate. So we have our example 1a, where we have y is equal to 2x. Again, y is the same as f of x. So where you see f of x or y, they are basically the same. So we have to differentiate this by the first principle. So looking at the first principle, we need to know what to put here, what to substitute for f of x plus h and f of x. We need to know what those quantities are. So we know that f of x is the same as y. So in our case, f of x is equal to 2x, because y is the same as f of x. So here where we are supposed to put f of x, what we are basically supposed to put here is the original function. So in place of f of x, what we are supposed to substitute here for f of x is actually 2x. Let's now look at the other quantity. We have f of x plus h. Where do we get this quantity? We get this quantity from the original function by substituting wherever we have x, we put x plus h. So for example, getting our f of x plus h from our original function, which is 2x, so where we have x here, we shall put x plus h. So we have 2. Now you can see where we have x here, we are going to put x plus h. So that our f of x plus h will be f of x plus h will be, when you multiply 2 by x and by h, you have 2x plus 2h. Oh yes. So when you have these two quantities, you are now at liberty to substitute these two quantities for f of x plus h and f of x. Let's now do the substitution. So we have dy dx is equal to the limit as h approaches 0 of f of x plus h. So where we have f of x plus h, we put our f of x plus h, which is 2x plus 2h. Then we, of course, we put it in brackets according to the rules of substitution. Whatever you substitute, you put in brackets. Minus, you can see here we have f of x. So in place of f of x, our f of x is actually 2x. So again, whatever we substitute, we put in brackets. Everything all over h. So we have substituted for f of x plus h and f of x. So that we have, let's remove the brackets. Continuing this limit, we have, you can see, 2x plus 2h minus 2x. So this gets to that. Everything over h. So that at this point, you look for like terms on the numerator. You can see we have 2x and we have negative 2x. So these two are like terms which we are able to add or subtract. So we have 2x, and minus 2x, which will give us a 0. So we are going to get rid of 2x and minus 2x. So on the numerator, we are just going to have 2h. On the denominator, we shall have the h. You can see the h is available on the numerator and the denominator. So we can easily cancel it out between itself on the numerator and the denominator. So we can easily say h there is 1 and h there is 1. So that finally dy dx will be given by 2. Don't worry about the limit here, because the limit of a constant is that constant. So finally, our dy dx of f of x is equal to 2x, or y is equal to 2x, is 2. Okay, let's move on. We look at the other example. So when we look at B, we have y is equal to 2x squared minus 1. So again, we need to know the values of, or the expressions for f of x and f of x plus h. So from this function, we know that f of x is just that function which is given. So in our case, f of x is 2x squared minus 1. So where we have f of x in the formula, we are going to substitute by the f of x that we now know. Now let's look for f of x plus h. As usual, f of x plus h, it means for us to get f of x plus h, we have to substitute for x in f of x. For x, we put x plus h. For x, we put x plus h. So you can see we have 2, then x. So for x, we put x plus h. Then you can see there is a power 2 and there is minus 1. Okay, so let's try to simplify it further so that we will be making our work easier. You can see f of x plus h is equal to 2. Now, we need to expand this one. We need to expand that one because we have x plus h to the power 2, which means x plus h by another x plus h. Okay, so we need to expand this one so that we come and put the expansion that we are going to get here. So we have, you know the rules of expansion. We are going to multiply this by that plus the same one by that. Then we shall get to the other term multiplied by that. So from here we shall have x by x, we get x squared. X by h, we get xh. And we come to this one, we have x by h by x, we get again xh. Then we have h by h, we get h squared. So that you can see we have 2 xh's. So we have 2 xh. We had this one and this one, we get this one. Then we have h squared. So wherever we have x plus h squared, we are going to substitute by this one. So similarly here, where we have x plus h squared, we put this expansion here. So we have x squared plus 2xh plus h squared minus 1. Okay? We are still in the process of getting f of x plus h, which we are going to substitute in the first principle there. So you can see when we distribute these two everywhere here, we are going to have 2x squared plus 4xh plus 2h squared. So distributing these two everywhere here in each one of these three terms, we have this. Then minus 1. Okay. So finally, our f of x plus h, which we are going to substitute in the formula, will be, you can see here, our f of x plus h is actually 2x squared plus 4xh plus 2h squared minus 1. So basically, this is our f of x plus h. This is our f of x plus h. Okay, so in the formula, where we are going to have f of x plus h, we are going to actually put 2x squared plus 4xh plus 2h squared minus 1. So basically, in the formula, where we are going to substitute for f of x plus h, we are going to put this expression. Okay, so in the formula you can see we have f of x plus h and f of x. So where we have f of x, we are going to put the original function, which is 2x squared minus 1. And where we are going to have f of x plus h, we are actually going to put in this expression. Well, this is the expression for f of x plus h, which you get by going through what we went through. Okay, so finally we have dy dx. Let's now get the actual derivative of b. So we have dy dx equal to the limit as h approaches 0 of... Now, we start the actual substitution. We have the numerators and the denominator will be maintained as h. Now the numerator, we have to substitute, we put f of x plus h. F of x plus h is this one. So we say 2x squared plus 4xh plus 2h squared minus 1. So actually this is f of x plus h. Now you can see this minus f of x. So our f of x is 2x squared minus 1. So remember, whatever we substitute, we put it in brackets. So this is our f of x, as in our formula. This is our f of x plus h, as in our formula. Then we have h. So we go on, we say dy dx is equal to the limit as h approaches 0 of, we remove the brackets, we have 2x squared plus 4xh plus 2h squared minus 1. We remove the brackets here. So removing the brackets here, we have minus times 2x squared, we have minus 2x squared, minus times minus 1, we have plus 1. Everything over h. Okay. We continue. So we have dy dx is equal to the limit as h approaches 0 of... Now, at this point here, we need to look for like terms. So as you can see, we have some like terms here in some like terms here in 2x squared and minus 2x squared. So you can see we are going to subtract these two. We have 2x squared minus 2x squared. This will go to 0. So these two would disappear. And we have minus 1, and also we have this one, minus 1, and also we have plus 1. These ones also are going to disappear, so that we are going to remain with our simple numerator as in 4xh plus 2h squared. That's it. That's what we are going to remain with as our numerator. Having subtracted 2x squared minus 2x squared, this will go to 0. Having also added and subtracted minus 1 plus 1, this will also go to 0. So we shall just have 4xh plus 2h squared over h. This is it. Now here, you can see that Actually, the h is common on the two terms that are forming the numerator. So we are going to substitute we are going to factorize the h so that we have h, then we have 4x, because here we would have substituted factorized the h plus 2h. So this is what we are going to have as our numerator. So you can see we have the two h's here on the numerator and the denominator. So we can easily say h is 1 and h is 1. So that we have our numerator in 4x plus 2h. We have 4x plus 2h. Now, the question that we have now is dy dx is equal to the limit as h approaches 0 of 4x plus 2h. So we have to evaluate this limit here. We have to evaluate this limit so that we get our dy dx. Now, evaluating this limit here, we are told the limit as h approaches 0. So we shall do it by direct substitution. Where we are going to have, example, where we have h, we are going to put a 0. So you can see we have 4x plus 2h, we put a 0 here. So that we have 4x plus 0 as our final answer. So you can see dy dx is basically 4x. But dy dx is basically 4x. So this is where we end our discussion on differentiation using the first principles. This is basically how we do it. We need to look for f of x plus h and the f of x. Actually, f of x is that particular function that you are given. Whilst f of x plus h, you need to substitute for every x in your function. You substitute with x plus h, then you simplify. That is the f of x plus h that you come and put in your final function. Thank you very much for your attention.